Hello, my brilliant scholars. Today we're looking at Chapter 5, Section 1, the Riemann pun. Oh, sorry, I meant to say Riemann sum. They really add up sometimes, you know? All right, what a happy day for us as we move forward. So right here we have the graph of an x-squared curve. But before we get started, let's learn what the Riemann sum's all about. It's an approximation of the area under the curve. It's an approximate integral. It's a decent approximation that it provides. Basically, a Riemann sum creates a series of rectangles. In some cases, these rectangles are going to over-approximate, and in some cases, they're going to under-approximate. More on that later, but let's get started. Let's say that we have the sample problem of x squared, the graph that we have right here, and we're told to find the Riemann sum from 0 to 16 with four subintervals. 4 subintervals, 0 to 16, and I know that we're going to be going over it by 4 every time. We also know that we're going to be doing a right Riemann sum approximation. So what I'm going to do is I'm going to go over 4, and then I'm going to draw up to the y value. All right, there we go. Draw up to the y value, then draw over. Now I'm going to go over to 8, and then head on up. Head on over to 12. Oh, there it goes. Okay. So what I'm doing here is I'm going over to the x value that I need for the subinterval, drawing a line up to its corresponding y value on the graph, and then drawing the rectangle over to the left value of its subinterval. So I have one here from 0 to 4, 4 to 8, 8 to 12, and 12 to 16, just like it asked. Now what I'm going to do is I'm going to find the area under these curves. So what I'm going to do is I know that the area of a rectangle is base times height, and I know every time my base is going to be 4, so I'm going to pull that 4 out, and then I'm going to add them up. I'm going to add up the y values. So I know that that's going to be 16, 64, 144, and 256. I was obviously able to see that from the graph. Very obvious there. And I get a total of 1,920. We can see here that this graph provides us an over-approximation because there is a considerable amount of area that the rectangles have that's above the curve, so extra area there. If we were to do a left approximation, however, we'd have an under-approximate because there'd be area under the curve we weren't taking account for. And a midpoint approximation would mean that we would go up, let's say we had the same subintervals for the first one would be 2 and then 6. We would draw up to find a midpoint approximation. Just to give you a heads up, you could also receive the similar type question in the form of a graph there, where we'd use those corresponding values where they're given to us, unlike the one before of the, don't know where we went there. Oh, there, okay, we're back. Unlike this one where it gave us the coordinates that we needed. Well, happy day, we made it through the Riemann sum.
Now, usually I don't do this, but we're going to sing a little song about math. Now I'm just sitting here listening to Campion doing her addition. Just can't take the anticipation of a new day of learning lessons. Now I would make this a big deal, but this quiz I can't fail. Campion just keeps it going with 50-minute videos rolling. So baby, give me that toot toot. Let me give you that beep beep. Running my pencil and from left to right to start on my approximation. Riemann sum estimation, got that curve in formation. Take left or right or midpoint, no exact values taken. Take right to over a star, curve that keeps going up. Let's take our Riemann sum and baby, let's have some fun.